So far you've heard the kind of theme about building the wireless infrastructure into the Internet of Things. And as well as looking into the existing infrastructure, we've also been working with top universities and companies on the next generation of wireless, what the industry is calling 5G. And to talk more about 5G, I'd like to bring to the stage Gavin Hill.
So, NI established its lead user program with the goal of furthering research initiatives in specific technical areas. Through collaboration with the leaders in these fields, we have helped and we're continuing to help to solve their research challenges using our tools and technologies. In 2010, we identified wireless research as an area that we wanted to target. And we've been working with leading researchers at companies such as Nokia ever since. Over the years, we've collaborated with more than 30 researchers from academia and industry to help prototype their innovative wireless theories using LabVIEW and the NI platforms.
Can you tell us more about Nokia's recent work?
Sure. Well, as I'm sure you're all aware, Nokia have been a leader in the mobile phone and wireless infrastructure sectors for many years. With the deployments of LTE and LTE Advanced, the research team at Nokia have started to look beyond 4G technologies into 5G. And a list of those research areas is on the screen behind me. Now, the 5G vision for high data rate applications is to have a peak data rate of 10 gigabits per second with a latency of less than 1 millisecond. Now, to achieve that vision, it's going to take several key technologies. But today, we're going to focus on the spectrum exploration and air interface research being conducted into millimeter wave. Nokia wanted to build a prototype to test a developed theory that millimeter wave spectrum could be used for ultra-dense deployments in a cellular environment. Now, there's plenty of licensable spectrum available within the bands between 6 to 100 gigahertz, but Nokia have to prove that communication at these frequencies is viable for a cellular network.
Are there any challenges of pioneering at these kind of frequencies?
Well, one major challenge that they experienced was finding a hardware platform and prototyping an environment that was capable of processing the 1 gigahertz of bandwidth in real time. Now, they had issues with this, and what they looked at doing was trying to just work out how they were going to cope with that network. So the generation leap that 5G represents clearly pushes the envelope of signal processing capabilities, and it goes beyond the capabilities of current 4G development platforms, both mobile and wireless, mobile and network, sorry. So they also needed a stable platform with a mature development environment. So after surveying numerous platforms, they approached our lead user team about possible collaboration and decided to work with ourselves on their 5G proof of concept system.
Can you tell us more about this system?
Sure. So for their 5G proof of concept system, they developed an access point, handset, and everything in between. Millimeter wave transceiver, baseband software, and of course the antenna system. Fortunately, they were able to use PXI as their baseband hardware. At NI Week this year, Nokia demonstrated a working baseband implementation of a full 1 gigahertz HDD or TDD access point and user device or handset. They used multiple Flex Rios as the FPGA boards that provided the real-time signal processing, doing things like modulation, demodulation, channel encoding, and decoding. Our team worked directly with the researchers at Nokia to develop an optimal system architecture to partition the physical layer from the higher layer across multiple FPGAs on the NI platform.
And how long would you say it took to develop this prototype?
Well, just to cover one thing quickly, it was very lucky in that with the use of these inter-FPGA communications, they were able to optimize the performance by using peer-to-peer technology pioneered by NI. And they achieved synchronization in the order of picoseconds using PXI trigger lines. But to get back to your question, this development took the Nokia team about 1 calendar year, which is half the time they would have expected using other approaches. Because of the flexibility of the platform, they were able to experiment with different Mach and Phi algorithms quickly. And due to the success of the prototype, they've decided to expand upon it to incorporate more aspects of the real-world system or real-world network. Things like handover, multiple user scenarios, etc.
That's great. Very impressive, Gav. Thanks again.
Thanks, John.